our exam to review with the final few questions. Okay. All right, so we want to give electron configurations in the SPDF format, right? And so if we have larger atoms, we're going to need to figure out which orbitals fill before which. And a handy way to remember this is to list the orbitals, okay, in this format where you write the 1s, then 2s, and then 2p. And so up to 4, you get a new type of orbital shape at each level. Okay, 4s, 4p, 4d, 4f. Okay, and then beyond that, we only have those 4 shapes. And so if you line them up this way, okay, and then 6s, 6p, 6d, and 6f, and then 7s, 7p, 7d, and 7f. Okay. All right, and so then to figure out what order things will fill in, you're going to draw diagonal lines, okay, going through your rows. Okay, so this means 1s would fill, then 2s, then 2p, then 3s, then 3p is going to fill before 4s, but 3d, okay, is going to fill, so 3d right here is going to fill before 4p, and so this is going to give you the order in which orbitals will fill. Okay. All right. So silicon, okay, is, we get look at it, it's over here, it's element number 14. So we have 14 electrons. So this is element number 14. Therefore, we have 14 electrons to place. Okay. So our s orbitals can have 2 electrons. So we go 1s2, and then our 2s orbitals will be the ones that fill next. So 2s2, right? So that's 4 electrons, so we need to place 10 more. So the next orbital that comes up, okay, is our 2p. And the p orbitals, we have 3 individual p orbitals, each which can hold 2 electrons. So we can have 6 electrons in the p's. So that gets us to 10, so we need to place 4 more. So then we go 3s2. That will be 2 of our orbitals. And then we start at the next, at our next diagonal, and that gets us to the 3p. Okay, so we have 2 more electrons left, and so those would go like that. Then we'd be 3p2. All right, so magnesium, okay, if we look at magnesium, magnesium is element number 12, right? So let's go to magnesium. Okay, so the neutral magnesium has 12 electrons. All right, but this is magnesium 2 plus, so that means it has lost 2 electrons, so this has 10 electrons. So now our electron configuration is going to be 1s2, 2s2, 2p6, and that's 6, 7, 8, 9, 10. That is 10 electrons, okay? All right. Okay, so the charge on the common ion of atoms are the following elements, okay? So just ignore the Lewis structure thing for now. We're really going to talk about Lewis structures when we talk about covalent compounds and bonding in covalent compounds more. For ions, let's just say that, a Lewis structure, you typically will draw it for silicon. It would be the element symbol in the middle, and then that symbol represents the core electrons in the nucleus, and you show the valence electrons by dots around the element symbol. So our silicon atom has 4 valence electrons, so we would put 1, 2, 3, 4 electrons around our silicon atom. Okay, and that would be that would tell us that there are 4 valence electrons. So, all right, and you would put up to 2 electrons in each side because you can have up to 8 valence electrons in your atom. All right, so let's get back to the common ions of the following elements. Okay, so let's look at, so we've got aluminum, potassium, sulfur, and bromine. Okay, so if we look just at the position on the periodic table, okay, aluminum is here, and aluminum is a metal. Okay, so remember that the aluminum is going to actually lose electrons, okay, to get to the nearest like D block element, okay, and so well, what we find, okay, is that aluminum is going to be one of those elements that forms a +3 ion, okay, and so if we look at aluminum, okay, it's in group 3A, which means it has 3 valence electrons. So for it to get down to like the next most stable structure where the valence is filled, it can either gain 5, which is unlikely, or lose 3. Okay, so aluminum is going to be +3. Okay, that's the charge on that ion. Okay, now let's look at potassium. So potassium is in group 1. They have 1 valence electron, so it's easier to lose 1 than it is to gain 7 electrons. Okay, so this is going to be +1. Okay. All right, now let's look at sulfur. Okay, sulfur is over here, and sulfur is in group 6A. So in order to, again, to get that full valence, it can either lose 6 electrons or it can gain 2, and to get to a nice full shell of 8. And so it's going to be easier for it to form a -2 ion by gaining 2 electrons. And we find, if we look at our table of common ions here, sulfur forms a -2 ion. And there's our potassium that we did too. All right, and then bromine. So bromine is a halogen. Okay, so bromine is a group 7 halogen. So that means it's got 7 valency electrons. So to form an ion, it gains 1. To form, so 1 electron to form a -1 ion. Okay. All right, so this is in group 6, gains 2 electrons. Right, this one is in group 1, and it forms its ion by losing 1 electron. And aluminum is over here. It's a metal in group 3A. So it's a group 3A metal, which means it will lose electrons and form a cation. Okay. All right, so the next thing we're going to do is we're going to name some compounds. Okay, so what we need to do is we need to identify, is it covalent or ionic first, and that's going to give us our clue to how to name it. Okay, all right, so the thing we're looking for in determining ionic is like a metal and a nonmetal. So this would be metal and nonmetal, or a polyatomic ion. Okay. And so if we look at this one, we've got our phosphate. Okay, and so that is a polyatomic ion. It's one of the polyatomic ions that you should remember and recognize. Okay. All right, so in the case of an ionic compound, the cation, which is the aluminum in this case, it just uses its name, aluminum. So this is an ionic compound. And then when we have a polyatomic ion, we just use the name of the ion. So this would be phosphate, aluminum phosphate. Okay. All right. So the next thing, okay, is FeBr3. Okay. So in this case, we have iron, okay, which is a metal. So iron is right over here. That's a metal. And then we have bromine, which is a nonmetal. Okay. So we know that this is an ionic compound. Okay. Because this is a metal right here, and this is a nonmetal. All right, so we're going to use the name of the cation, which is the one that comes first. That's the iron. So we're going to call it iron. And then iron is one of those transition metals that's in the middle that can have different charges, right? So we're going to have a Roman numeral in parentheses. And so let's figure out what that Roman numeral is. So if we look at bromine, bromine is a halogen, and bromine forms a -1 ion. And so because bromine forms that -1 ion, all right, the total charge that the iron has to neutralize in this case is -3, because we have 3 bromine ions that have bromide ions, I should say, that have a -1 charge. Okay, so the last part of the name is going to indicate the bromide ion. So we use the IDE suffix for the anion. And again, we have to have 3 positive charges to balance our 3 negative charges. So that means that iron is in the +3 oxidation state. And so we put the Roman numeral 3 in the name to indicate that it's iron 3 bromide. Okay, so now let's look at our last compound is made of phosphorus and chlorine. So if we look, phosphorus is a nonmetal, chlorine is a nonmetal. 2 nonmetals mean that we have a covalent compound. So let's change the color here. We'll make it pink. Okay, so this is a covalent compound. So when we name covalent compounds, we're going to use the prefixes. So we have 2, which is di, okay, and then we have a 3, which is tri. Okay, so this is going to be diphosphorus, tri for 3, chlor for chlorine, and then we're going to end with IDE as the suffix. Okay, trichloride. All right, so now let's first, we'll give the chemical formulas, but we're first going to identify which of these things are covalent versus ionic. Okay, so we have chlorine and fluorine. Chlorine is over here, fluorine is over here. They're both nonmetals. Okay, so that is a covalent compound. Also, we can tell it's covalent because we have the di there. Okay, anytime you see one of those prefixes, those number prefixes, you know that it has to be a covalent compound. Okay, now let's look at the other compounds and then we'll go and write the formulas. So here we have chromium 3 nitrate. Okay, when I see one of these numbers in parentheses, that I know it's telling me the oxidation state of a metal cation, so I know this has to be ionic. Okay, so now we can say that this one is ionic. Okay, and then this last one, okay, is made up of two of the polyatomic ions, which we are expecting you to know, so ammonium and sulfate. Okay, so this is also an ionic compound. So let's start by trying to write the formula for chlorine difluoride. So I'm going to start with each of these by writing the formula, okay, so Cl for the just the chemical symbol for the elements. So I've got Cl for chlorine and F for fluorine. Okay. And now what I do is I use subscripts to indicate how many of each atom type there are. So I only have one chlorine because there's no prefix in there. So I don't need to write a 1 there. Now the fluorine, I have 2, so I need to write the 2 there. Okay, so that's chlorine difluoride. All right, so next we have chromium 3 nitrate. So again, we're going to start with the symbol for the element. So chromium is over here. It's capital C, lowercase r. Okay, so that's our chromium. Okay, now the 3 does not tell me what the subscript is, but it tells me the charge on the chromium ion. So I'm going to write over here chromium 3 plus. Okay. All right. Now, nitrate is one of those polyatomic ions that we want you to know. Okay. Oops. So nitrate, NO3 minus. Okay. And so NO3 minus, okay, has a -1. Okay. And that's the charge on the, oops, let me clean this up a little bit. All right, so the charge on the NO3 ion is -1. Okay, so I'm going to need how many of those to balance the chromium's charge? Okay, now remember, so I will need 3 of those, right? So if I have 1 minus, then I will need 3 minuses to balance 3 pluses. So, but the other thing to remember again is that whatever the charge on the ion is, it's going to become the subscript on the partner's chemical symbol in the chemical formula. So the 1 would go with the chromium, and then NO3 is going to have to go in parentheses because that acts as a unit. And so this is going to be, whoops, that's going to be a 3 subscript on that. So that's the formula for chromium 3 nitrate. All right, and then ammonium sulfate is made up of, again, 2 of the ions that we want you to remember, ammonium and sulfate. So sulfate has a -2 charge, and ammonium has a +1 charge. So we've got NH4. So if I do over here, NH4, okay, it has a +1 charge. And our sulfate, SO4, has a 2- charge. All right, so if we're using, again, our little crisscross to determine what our subscripts are going to be, okay, then the ammonium is going to get a 2 for a subscript because it's going to take 2 of those positively charged ammonium ions to balance the negative charge of a single sulfate ion. So that's going to be the symbol for ammonium sulfate. Okay. All right, and that's it for the exam review.